Hello, friends. We're going to start with reviewing rationals because it's everyone's favorite unit, obviously. A large part of the diploma is based on it. And so what I would suggest is to attempt the questions on your own and then watch the podcast to see if you got it right. But don't just do them with me, try them out on your own first. So the first thing we did in rational functions was non-permissible values. Values is the variable that results in the value of a rational expression not being defined, so the denominator equaling 0, also known as restrictions on the variable. Non-permissible values and restrictions are the same thing. Non-permissible values of rational equations can be found by 1. Solving an equation by setting the denominator equal to 0. Often, factoring out a GCF or difference of squares is required to determine the NPVs. So you have to do that first before you solve. So if all I'm doing is asking you for non-permissible values, you can look directly at the denominator and not be concerned at all with the numerator. So I look at the denominator and I say, okay, well, the denominator is, I need a pen, and I have my board that I did super enjoy, so we'll see how this goes. So I have to take a negative 2 out of my denominator first, and I'm left with x plus 2. Now, had you forgotten, you would still luck out in this case. But it's often easier if you do take out the GCF and difference of squares first, always before you state your non-permissible values. So we have this one here in front in the bracket, which is negative 2 can't equal 0, but that's just a true statement. That's not an actual non-permissible value, so I don't really care about that. And then I have x plus 2 can't equal 0. Subtract 2 from both sides, and x can't equal negative 2. Now remember, I told you try these on your own first and then come back to check and just see if you got them right. You can even play in 2 times the speed so I'm faster if you're getting them right. If you're not getting them right, you can watch the whole process and see. Or if you completely forget, you can watch a couple of them and see if you can still do it after that. All right, so the next one, I can take a p out, a GCF of a p. And then I'm left with 4p minus 1. Now, I'm not concerned with the numerator at all because all this question asked me to find is the non-permissible values. If I was concerned with the numerator, it would be a simplify or an adding, a subtracting, a multiplying. So here I'm going to get 2 non-permissible values from both of the brackets. So I'm going to get p can't equal 0, and that one's a done. And then this one I'm going to get 4p minus 1 can't equal 0. Add the 1 over. 4p can't equal 1. Divide by 4. And p can't equal a quarter. So those are my 2 NPVs. And often, like I've said before, they're written together as p can't equal 0, comma, a quarter. Now this one, a squared minus 49. Remember, if you're stuck, often it's that it's a difference of squares. That's what I told you guys. So a squared minus 49 breaks into the square root of a squared is a. Square root of 49 is 7, and I need a minus sign in between, which I do, so that's the difference of squares. So I'm going to get a plus 7 and a minus 7. And I have a plus 7 can't equal 0. A minus 7 can't equal 0. Subtract my 7 over, so I get a can't equal negative 7, and a can't equal 7. And I'll often write it as together as plus or minus 7. Now D is a trick question. If I take a 2 out, which I can take out a GCF of 2, I'm left with x squared plus 4, which is an addition of squares. Whenever you get an addition of squares, there's no NPVs, because there's nothing that I can fill into this x that would make it cancel off. So for example, if I have x squared plus 4, I'd have to fill in something that would be negative 4 plus 4 to give me 0. And there's no way I can do that, because when I square anything, it becomes positive. To prove my actual point, I can say x squared plus 4 can't equal 0. And then I subtract my 4 over. And I get x squared can't equal negative 4. And then I take the square root with plus or minus sign. But I can't take the square root of a negative number, so no non-permissible values. Or restrictions. So that's NPVs. Then we have equivalent forms. Now, equivalent forms means if you're asking for an equivalent rational, you can multiply the top and the bottom by the same thing, or you can divide the top and the bottom by the same thing. Okay? But it has to be done to the top and the bottom. That's equivalent. Simplifying, you have to cancel something off. That's the same. So it's only division. But equivalent, you can multiply or divide. Which of the following are equivalent forms of the rational expression? So, we have to see which of the following are. Now below I've given you answers to all of them, but we're going to prove why on here, and obviously, like I said, I want you to do it on your own anyways. So we have 20x squared minus 60x. Let me change my color to blue. It's more noticeable. And I want to get it to be equal to this expression. So I say, okay, I have 20x squared, I need it to be 2x squared. So I'm going to have to divide the top by 10. The numerator by 10, but also then the denominator by 10, because when I do the top, I have to do the bottom, but it's an equivalent. So let's see if I get the actual answer. 20x squared divided by 10 is 2x squared. 60x, negative 60x divided by 10 is negative 6x. All over 40x cubed divided by 10 is 4x cubed. Now, does it match? Yep, so it's equivalent. Perfect. Now I look at 2. And I say, what do I have to do to x squared to get 2x squared? Well, I have to multiply by 2. And because it's equivalent, when I do the top, I have to do the bottom. So on the top, I'm going to get 2x squared minus 6x. And on the bottom, I'm going to get 4x cubed, which every single term matches, so I know I'm right. It's equivalent. Now I look at this one. I have 2x. I need it to be 2x squared. So I'm going to times the top by x. And then when I do the top, I have to do the bottom and see if I get the same thing. So I get 2x times x is 2x squared. And then negative 6 times x is negative 6x all over 4x cubed. It matches, and we're good. And this last one, I have an x. I need it to be a 2x squared. So I'm going to have to multiply the top by 2x, which means I'm also going to have to multiply the bottom by 2x. So I get x times 2x is 2x cubed, and then negative 3 times 2x is negative 6x, and then 2x squared times 2x is 4x cubed, and it matches. So they're all equivalent forms. Some of them are multiplied, some of them are divided. Now here it wants, which of the following is equivalent to the rational expression? 2x plus 3, 2x plus 1. So I'm going to look at A first. I know there's an answer down there, I don't really care. Remember, we're covering up the answers as we go along. And if we don't get them right, we can watch the video. If we do get them right, we can check the video to make sure we did them right. But you're covering up the answers as you go along so that you don't have them there, so that you're not drawn to them. So you see if you're drawn to the errors. So I have x plus 3 over x plus 1. I need it to be 2x plus 3, so I'm going to have to multiply by 2. If I do the top, I have to do the bottom. So I'm actually going to get 2x plus 6 over 2x plus 2, which does not match. So it's not equivalent. Now I'm going to try B. Remember, like I said, put a piece of paper over the answers. Write the paper down and cover your answers as you go along. Oops. So the board hasn't changed over holidays. Still jolted. Okay, so B is 2x plus 4 over 2x plus 2. Well, immediately it's not correct because I have 2x, and I have 4 and a 3. So that's not equivalent. C is 4x plus 5 over 4x plus 3. I would have to divide by 2 to make it 2x, top and the bottom. When I divide by 2, I get 2x plus 5 over 2 over 2x plus 3 over 2, which doesn't match. So that's no good. Now let's try D. D is 6x plus 9 over 6x plus 3. I need to match 6x to 2x, so I'm going to have to divide the top by 3, which means I have to divide the bottom by 3 because it's equivalent. You have to do the same to the top and the bottom. 6x divided by 3 is 2x, plus 9 divided by 3 is 3, over 2x, 3 divided by 3 is 1. Now please, this is equivalent and it matches. When you're going along, please don't just watch me do math. That is not the way to study. The way to study these questions that I'm giving you is to go to the question, cover up the answer with your piece of paper, attempt the question, check the answer. If you're right and you know you did it right, you don't have to watch that part of the video. If you want to, you still can. If you get it wrong, you go back, you watch the part of the video where I explain this, and they'll help you out, okay? But you're covering up the answers as you're going along, and you're attempting them first. You're not just watching the video, watching me do it. That is not helpful to you. Okay. Here we have the rational expression ax squared, so I'd be covering up my answer with my piece of paper and attempting the question. The rational expression ax squared minus 3 over bx plus c is equivalent. It's an equivalent form, so I know I need to either multiply the top and the bottom by the same thing or divide the top and the bottom by the same thing. It's an equivalent form of the rational expression 2x squared minus 1 over 3x plus 1. Write the value of a in the first box, b in the second box, and write the value of c in the third. So I've read the whole thing. So I'm prepared to do the question. I know that they're equivalent, so I have to multiply or divide the top and the bottom by the same thing. The only thing I have to compare here is that this one is a negative 3 and this one is a negative 1. Well, how can I get from negative 1 to negative 3? Well, I have to multiply by 3. And when I do the top, I have to do the bottom because it says an equivalent form. So let's put that 3 through. So I get 2x squared times 2x squared times 3 is 6x squared. Negative 1 times 3 is negative 3 over 3x times 3, which is 9x, and then 1 times 3, which is plus 3. Now I can put my form that they want. They want ax squared minus 3 over bx plus c. So it says that the a is located in front of the x squared. So the 6 is located in front of the x squared, so that was my first box. The b is located in front of the x, so the b is a 9. The c is what's located after the plus sign, not including the plus sign, what's located after. So it's a 3. So my answer should be 6, 9, 3. That was equivalent. Same thing to the top and the bottom. Now simplifying rational expression. A rational expression is in simplest form when the numerator and denominator have no common factors other than 1. Often you must factor out a GCF or difference of squares to simply simplify, cross off common factors. So when it's simplifying a basic rational, multiplying and dividing, our first steps always are to GCF, difference of squares, the numerator and the denominator. So we need to remember that. When simplifying, multiplying, and dividing, our very first step we have to remember is simplify, GCF, difference of squares, numerators and denominators. All right. Write the following rational expression in simplest form. State restrictions on the variable. So I look at the numerator, and the first thing I say is, what can I take out? GCF, or difference of squares. And I can take out a 2 and a p squared. When I do 2p cubed, take out a 2p squared, I'm left with a p, minus 4p squared divided by 2p squared, I'm left with a 2. And then remember, the 2 and the p squared can go in their own brackets because they're monomials. Then I go to my denominator and I say, what can I take out of 16 minus 8p? And I can take out an 8. When I take an 8 out, I'm left with 2 minus p. I specifically took this out the wrong way to remind you of this. I told you this will happen on the diploma and on unit tests and on everything that I'll ever give you. These are the same but wrong signs. So I have p minus, positive p minus 2, and I have positive 2 minus p. So instead of taking out a positive 8, I should have taken out a negative 8, and this would be a negative 2, and this would be a plus p. And they can be out of order, they just need to be the right signs in front of the terms. So positive p, negative 2, now they match. Now I get excited when I see that they match, because I know I'm doing something right, and I want to cancel them off. Remember, slap your hand and be like, have I stated NPVs? If you have not stated NPVs, you need to. So over here, I'm going to say they say restrictions. I'm going to say restrictions. So I have -8 can't equal 0. That's just a true statement. So that is not an NPV. So I can cross it off. And then I have -2 plus p can't equal 0. I just add my 2 over. And p can't equal 2. Now remember, you can always check your NPVs. If you plug it back in, your denominator should become 0. So if I plug it into here, I'd go 16 minus 8 times 2. 16 minus 16, that's 0. So I know I'm right. I've checked it, and I know my NPVs are right. Now I can go in and cancel anything that matches. Remember, anything with a plus or minus sign is sewn together, and that binomials can only cancel off binomials, so things with 2 terms, and monomials can cancel off monomials. A binomial can't cancel off a monomial, and a monomial can't cancel off a binomial. So here I have p minus 2 sewn together, and at the bottom I have -2 plus p sewn together. Positive p, -2, so they match, so they can cancel. The p squared is going to stay because there's no p's, p cubes, p anythings on the bottom. And then 2 and -8, I can take a 2 out of. So 2 divided by 2 is 1. -8 divided by 2 is -4. So I'm left with a p squared on the top, because 1 times p squared times 1. Remember, those slanted lines are just ones. And then on the bottom, I'm left with -4. And then I have p can't equal 2. I always follow behind my non-miscible value for my restriction. So here we have a multiple choice question. Look, there's an answer, but I'm going to cover it up. I don't want to know the answer, so I'm always going to go along and quickly try and cover up the answers. So I'm going to look at this and I'm going to say, okay, it's just a plain old simplifying question. When I get a plain old simplifying question, I have to GCF difference of squares the numerator and the denominator. It's the very first step. My brain power, I don't even need it. That's just what I know I'm going to do every single time. So I have x cubed minus x over x squared minus x. I'm going to rewrite it. And then I'm going to say, what can I take out of the numerator? And I have equal signs running down the left-hand side, except for when I'm solving, but I'm not solving, so equal signs running on the left side. So I can take an x out, and then I'm left with x squared minus 1. In the denominator, I can take an x out, and I'm left with x minus 1. Now remember, I told you, 99% of the time, if you can't get it to simplify in a form that you need it to simplify in, that often it just means that you can do more. Now, this answer is in this form here. The x squared minus 1 and the x minus 1. Most often they'll keep going. I'll show you what other answer we get. But before we go to cancel anything off, I see the numerator is the difference of squares. So I can get an x plus 1, x minus 1. Now I know this isn't helpful for this question because it is x squared minus 1. It's fine. But I'm going to do this anyways. Because you're going to have to keep going. If you try and do C or D, it's actually not in the most simplified form. So we have to remember that difference of squares. If we don't remember that difference of squares, we're going to come into a problem here because we're probably going to pick C, and the answer is not C because that's not a simplified form. Before we see that there are things we can cancel, we get excited. But before we do that, we always have to state our non-permissible values. So we have restrictions. Our non-permissible values, doesn't matter which word you use. Don't use NPVs. We don't short form on any part of the diploma or unit test. So we have x can't equal 0. And then we have x minus 1 can't equal 0. Add 1. X can't equal 1. Okay. Now the x and the x cancel. The x plus 1 does not cancel. That's an oopsie on my behalf. Let me get that out of the way. X minus 1's cancel, sorry. And then I'm left with x plus 1 over 1. Question, do I need to keep the denominator if it's a 1? Do I have to write it? No. I do if it's in the numerator, because it does matter. But if the 1's in the denominator, I don't need to write it. So I can write x plus 1, and then behind them I'm going to follow with x can't equal 0 and 1. Now remember, you always state non-permissible values before you cancel. If you go to cancel, slap your hand and be like, have I saved my NPVs? If I have not, I need to go back. So it's B. Okay. And next page. So here's an answer again, but I'm going to cover it up. I'm actually going to squiggle over it so I can't see it, because I can't cover it up. Okay, so here it says, with appropriate restrictions, I'm still going to state them anyways because I'm a rebel. The simplified form of 2b squared minus 18b over b minus 9 squared is. Now, first thing I'm going to do is rewrite it. So I'm going to go 2b squared minus 18b over b minus 9 squared. Now, the moment I see this squared, I say, nope, you're there to wreck me, you're there to mess me up, so I'm going to cross your squared off, and I'm just going to write b minus 9 again. I'm going to write it twice. Because I know that the moment I see that squared, if I cross it off, I have a much better chance of not making an oopsie. So, that's the very first thing I'm going to do. Now, I'm going to say, okay, what can I do in my numerator? GCF or difference of squares. It's a basic simplifying, that's what I'm going to do every time. I can take out a 2 and a b, and I'm left with b minus 9. And the 2 and the b can go in their own brackets because they're a monomial. In the bottom, I have a b, and a b minus 9, and another b minus 9. Now, I see things can cancel. I'm getting excited, but before I go to cancel, I have to say to myself, no, stop. Don't be so happy about this. You need to state NPVs. I know this one says with appropriate restrictions, so we wouldn't have to, but I always do it because it's better if you do. So my non-permissible values are we're going to have to do the b can't equal 0. That one's done. And then b minus 9 is the same, even if I do it twice. So I'm going to go b minus 9 can't equal 0. Add 9. B can't equal 9. So the b minus 9's cancel, the b's cancel, and I'm left with 2 over b minus 9, and then b can't equal 0 over 9. See. And the answer was da, da, da. All right. Multiplying. Okay, same rules go. If it's multiplying or it's dividing, we should GCF difference of squares, all the numerators, all the denominators. If we start with that first step every single time, we won't get overwhelmed. Then adding and subtracting and solving do the exact same steps as well in the first steps. So we do the same steps both ways here. So here we have, consider the following, consider the rectangle shown. So we're going to look at this rectangle right here, it's shown. That's what that's saying. Write and simplify an expression. So we're going to write the expression and simplify it for the area of the rectangle. Now an area of a rectangle is length times width. Remember when we did this before, it was perimeter as well. We did area and perimeter. Area was, or area is length times width. Perimeter is 2 lengths plus 2 widths. So it becomes a multiplication question, or it could become an addition or question if it was a perimeter. So these can be asked, anything like this. Now, my length is the longer one. If you put the width first, that would be the least of your worries. This would be totally fine. So area, we still have to write because it's an expression. Area equals 2x cubed plus 4x squared over 5x. And then my width is 20x over x plus 2 squared. So that's writing it out. Then my next step is to simplify. All my numerators, all my denominators. So I have 2x cubed plus 4x squared. I can take out a 2x squared, and then 2x squared out of 2x cubed is an x. 4x squared, take out 2x squared is the plus 2. And the 2 and the x squared go in their own brackets. All over, 5x is a monomial, so the 5 and the x can go in their own brackets. You can do the big brackets, or you can do a dot in between. I never do the x, because the x, which is a multiplication symbol, looks like an x, which we have as the variable, and it just gets really confusing. 20 and x are a monomial, so I'm going to go 20, and I'm going to go x. And then I have this x plus 2 squared again, which I am going to ignore that squared, and I'm just going to write it twice so I don't mess up. Now, non-permissible values are stated for denominators, because denominators can't equal 0. We don't care about numerators, we just care about denominators. So over here, I'm going to state my restrictions. Multiplication is just the denominators. So I'm going to get 5 can't equal 0. Don't have to write it because it doesn't have a variable. X can't equal 0, so that's one of them, which makes sense. And then x plus 2 can't equal 0. X can't equal -2. So those are my two restrictions. Perfect. Now, my next step for multiplying, after I've reduced all my numerators and all my denominators, is to write a full numerator over a full denominator. And then anything in the top and the bottom that can cancels. So, I have 1x plus 2 can take off 1. It's a 1 for 1 special. The 5 and the 20, I can take a 5 out. 5 divided by 5 is 1. 20 divided by 5 is 4. 1x for 1x. And then I think I'm as simplified as I can be. If I can't, I'll catch it in the next step. No big deal. I'll just end up doing an extra step. So I'm going to get this equals, in the numerator I'm left with a 2, an x squared, and a 4. 2 times 4 is 8. X squared, not sure why I made the line so long. And then in the bottom left, 1, 1, and x plus 2. And behind it I can state x can't equal 0 or -2. Then calculate, well, let's cover up that answer. Calculate the area of the rectangle if x is 3. So now it's giving me x is 3. That's the area. So I know my area formula is simplified as 8x squared over x plus 2. But now I'm going to fill in a 3. So I'm going to get area equals 8 times 3 squared over 3 plus 2. So 3 squared, which is 9 times 8, which is 72, over 5. And 72 divided by 5, hopefully is 14.4, because that's all the answer. 14.4 centimeters. The area of the rectangle if x equals 3 centimeters is 14.4 centimeters squared. I still don't picture squared, it's an area. All right. Okie dokie smoky. So, next page. There's another multiplication. I'll leave my answer covered up. So here I have 3x minus 7 squared. So the first thing I'm going to do is write 3x minus 7. And they want it to reduce to something. So let's see what it reduces to. I write that out twice. The x minus 1. I'm going to put in brackets. Remember, I bracket anything that is a binomial because it is attached. Times, I can take a 4 out, and then I'm left with 1 minus x. And then the bottom is the difference of squares. 9x squared minus 49 is 3x plus 7, 3x minus 7. It states the NPVs already, 7/3, -7/3, and 1, which is good. That means my denominators are right. and write a full numerator over a full denominator. And then I say, okay, 3x minus 7 crosses off one of those. And then I have x minus 1 and 1 minus x. So those are the same, so I can cancel them. No, they're not. We're setting you up. Remember, I told you there's going to be questions like this. So we have a positive x and a minus 1, and here we have a positive 1 and a minus x. So they're the right terms, wrong sign. So I should have taken out a negative 4, and then I'll have a minus 1 and a positive x, and now they actually match. And then I can write what's left over. So I'm left with negative 4, 3x minus 7, over 3x plus 7. And it can go in brackets or not in brackets, it doesn't matter because it's sitting there by itself now. The negative 4 can stay with the 4, or it can drop in front like this one has it right here. Because the negative, as long as there's only one, it can stay on the 4, it can move to the bottom, but it can only be in one place. So let's do. Okay. This one says with the appropriate, and I'm going to go like this. With the appropriate restrictions, the product. Product means multiply. It means the answer to multiplication. The product of 2x or 12x minus 24 over 3x squared minus 12 times 6x plus 12 over 2 reduces to a whole number. A whole number is the number with a whole and above. So 0 and all the naturals. 1, 2, 3, 4. The value of k is what? So it's going to break itself down to a whole number. So I have 12x minus 24 over 3x squared minus 12 times 6x plus 12 over 2. My very first thing I'm going to do, is GCF difference squares all the numerators, all the denominators. So the top left I can take out a 12, the numerator on the left, and I get x minus 2. And the 12 can go in its own brackets. It's mono. The bottom I can take out a 3, and I'm left with x squared minus 4, which I spot as the difference of squares, so I'm going to deal with that in the next step. Times, take 6 out, I'm left with x plus 2, and then a 2 in the denominator. I know this is the difference of squares, so I'm going to do another step. I'm going to get this equals 12 x minus 2 all over 3 x plus 2 x minus 2 times 6 x plus 2 all over 2. Now my NPVs are going to be based off the x plus 2 and the x minus 2. So I have x plus 2 can't equal 0, x can't equal negative 2, x minus 2 can't equal 0, x can't equal 2. Now I know it didn't tell me to do this, but I show my NPVs all the same ways. And the 2 and the 3 are not problems. All right. Full numerator over full denominator. X plus 2 cancels off the x plus 2, x minus 2, x minus 2. 6 divided by 3 is 2, 3 divided by 3 is 1, and then 12 and 2, 12 divided by 2 is 6, 2 divided by 2 is 1. Now remember I told you this, if you don't want to do the coefficients till the very last step, remember you could just go 12 times 6, and then you can go 3 times 2, and then you can reduce that at the very end. You don't have to cross it off like this if this is confusing to you. Now what is left over? 6 times 1 times 1 times 2 times 1 times 1 is 12. Over 1 times 1 times 1 times 1 is 1. So it's just 12. Now we have division. Division creates only one problem. Division is one step away from multiplication. And you end up with an extra non-permissible value because your non-permissible values come from B, D, and C because the C and the D switch when you multiply. So here it says simplify states non-permissible values and restrictions of the variable. So what I'm going to have to do is I'm going to have to still GCF difference squares all the numerators, all the denominators. That doesn't change. So in the numerator on the left, I'm left with 4x squared minus 1, or 4a squared minus 1, so I'm left with 2a plus 1 don't know what the heck this thing's doing. Change it to a different pen. Put it back. See if that fixes it. 2a plus 1, 2a minus 1. Yep. The bottom is the difference of squares, but I can take a 4 out first. So I always check for GCF first. So if I take that 4 out, I'm left with a squared minus 4, which a squared minus 4 is the difference of squares. So I get 4, a plus 2, a minus 2. So I always check for GCFs first, then difference of squares. And the 4 can sit in its own brackets. Multiplied, these flip. When I multiply, so I'm going to get 2 minus a. If you want, I told you this, you can write it in the correct form. So negative a plus 2, put the letter first, then it's easier to spot they don't match. And then on the bottom I have 2a minus 1. Now I see I have a positive a minus 2 here, I have a negative a plus 2. So if I just take a negative 1 out, this will become a plus a, and this will become a minus 2, and then they'll actually match. Before I cancel, I have to state non-permissible values of everything but the top left, because this was division. So my restrictions come from both denominators and the right numerator. So 4 can't give me an MPV, a plus 2 can't equal 0, a minus 2 can't equal 0, negative 1 isn't an issue. A minus 2 I already have up here, and then 2a minus 1. So this is going to be a can't equal negative 2. This is going to be a can't equal positive 2. And this one I'm going to add 1. 2a can't equal 1 divided by 2. And a can't equal half. Okay. Now anything in the top and the bottom that matches, I can cancel. So 2a minus 1 cancels, a minus 2 cancels. Now some people say, well, can I take the 2 off? There's a 2a plus 1 and the 4. No, the 2a plus 1 is in brackets altogether. 2a plus 1 is only going away if there's a 2a plus 1 in the denominator, which there is not. So I think we're as reduced as we can do it. So we get negative 1, 2a plus 1. Negative 1, 2a plus 1, all over 4, a plus 2, a can't equal plus or minus 2, and a half. And there you go. Okay, we have another division, which kind of looks like a multiplication symbol. There's an answer B. I can't mark it off, but I hope that you've covered up with your paper before you attempted the question, and I hope you attempt the question before you watch me do it. Okay, so we have a 15. 4a can't equal negative 3 halves and 0. They already stated the MPVs, and we have this rational expression as a division. Can be simplified to the bottom. So we get 4 and a squared in separate brackets, a minus 1, over a, 2a plus 3, multiplied by the denominator moves up, so 10, its own brackets, 2a plus 3, in the denominator I get 3 and an a. All right. The restrictions are already stated. So anything that matches I can cancel. So 2a plus 3, 2a plus 3. An a and an a squared cancel. And like I said, I'm going to show it to you if we don't even reduce anything. So say I don't even like the crossing off. Say I don't do that. I go 15 times 10, which is 150. A minus 1 over 3. And now I can cancel off if I don't. If I just want to bring them all down and make that extra step, I can totally do that every time. So I know some of you like doing it that way. So 150 divided by 3. 3 divided by 3 is 1. 150 divided by 3 is 50. So I'm left with 50 a minus 1 over 1, but I don't have to put the 1 if it's in the denominator. I do if it's in the numerator. So you should be getting B. Now this one has an answer of 32. I'm just really, anyways, hopefully you're crossing these over. Hopefully you're testing these out before you even watch mine. So it says, when simplified, the complex fraction 20x minus 12 for x minus 3 over 5x minus 3 over 2x squared minus 18. This is a division symbol. So we're going to write it sideways up here. Reduces to a linear expression. Linear expression, we know what these are. We've done linears, quadratics, cubics. Of the form ax plus b. It needs to be in that form, ax plus b. There's no brackets in there. It needs to be in the linear form, ax plus b, no brackets. Then the value of a plus b is what? Okay. So we're going to get 20x minus 12 all over x minus 3 divided by 5x minus 3 all over 2x squared minus 18. So, left-hand numerator, I can take out a 4, and then I'm left with 5x minus 3. Left-hand denominator, x minus 3, there's nothing I can do, so I'm going to put it in brackets. Times, these are going to swap, so the 2, I can take out and I'm left with x squared minus 9. I spot that's the difference of squares, so I'm going to get an extra step here. Over 5x minus 3. Before I do any simplifying or NPVs, I need to change that x squared minus 9 into a difference of squares, 2 factors. So I'm going to get 4, 5x minus 3, all over x minus 3, times 2, x squared minus 9 is x plus 3x minus 3, all over 5x minus 3. Sure, so recording, or I'd be crying if I wasn't. Oops, long recording. All right. My non-permissible values are going to come from, I'll just do them over here. I know we don't have to have them, but I'm proving the point. Because everyone should get the NPV question, right? If there is one. Everyone. So we have x minus 3 can't equal 0. 2 can't equal 0 in the numerator, remember, because this was a division. X plus 3 can't equal 0. X minus 3 already stated. And then 5x minus 3 can't equal 0. So I add 3. X can't equal 3. Subtract 3. X can't equal negative 3. Add 3. 5x can't equal 3. Divide by 5. X can't equal 3 times. All right, full numerator over full denominator. X minus 3 cancels, 5x minus 3 cancels. And I'm left with 8x plus 3. Now people tell me it's 8 plus 3, which is 11. You're wrong. This needs to be ax plus b. Do you see a bracket in that? No. So they're expecting you to distribute this 8 in first, then add. So we're going to get 8x plus 24. This is my A. This is my B. We do 8 plus 24, which is 32. Addition and subtraction, totally different rules. So adding, subtracting, and solving are together. Simplifying, multiplying, dividing, same steps. So simplifying, multiplying, dividing, we add, subtract, we GCF difference of squares, all the numerators, all the denominators. Adding and subtracting, our very first step is to simplify only the denominator and then make a common denominator. Okay? So simplify only the denominator, then make a common denominator. So here we have 3 over x plus 1. And it'd be 1 over 1 if we want. Written as a single rational expression, so they want you to put it together by addition. The only way we can put it together is a common denominator. So monomial denominators we can make be the same. So we multiply by x and by x. So I'm going to get 3 over x plus x over x, which is 3 plus x all over x, which is d. Now this one, it says for some whole number k, k being 0 and above, that's what a whole number is, the reduced form of these added is this. This is the answer. What is the value of k? So we get x minus k all over 2x plus x plus 1 all over 4x. Now these are denominators that are monomials, so I can put them in brackets. And it says this equals, the answer to this is 3x minus 5 over 4x. So I know in order to put them together I need a common denominator. The left-hand side I need to multiply by 2. Remember, monomial denominators can make be the same, but binomial and monomial you can never. You have to multiply them by each other. So we're going to multiply this one by 2, and we're going to multiply this one by 2. So we get 2x minus 2k over 4x plus x plus 1 all over 4x. Now I'm just going to keep going and solve this out and then see what I have to do to get it to be this. So I have same common denominator, so I can write it all over one denominator. So I get 2x minus 2k plus x plus 1. Remember, if it's a minus sign, you have to remember to distribute it to the binomial behind, but if it's a plus sign, it doesn't matter. Then I collect like terms. So I'm going to get 2x plus x is 3x minus 2k plus 1 over 4x. Now that has to equal 3x minus 5 over 4x, right? Well, this has to equal 3x minus 5. So we're going to get 3x minus, or 2k plus 1 has to equal 3x minus 5. Well, the 3x's cancel off. Now I have 2k plus 1 has to equal negative 5. Subtract 1. Negative 2k has to equal negative 6. Divide by negative 2. K equals 3. We will spell them left to right. So the only thing we're not covering in this rational review is word problems, because we're going to cover them when we come back. We were supposed to do them before we left, but we didn't. All right. So here we have t plus 1 over t minus 1 minus t minus 1 over t plus 1. Now I see these are binomial denominators, and binomial denominators cannot be made the same, so you end up just multiplying by each other. So we're going to go t plus 1 over t minus 1 minus t minus 1 over t plus 1. So I have to multiply them by each other to get a common denominator, or I can't subtract. So I'm going to multiply this one by t plus 1. So my denominator is t minus 1, t plus 1. And I'm going to multiply this one by t minus 1. So I have to FOIL the top. Remember, we don't do the bottoms. We keep the bottoms, FOIL the tops. So always just keep the bottoms. So we're going to get, and we can put them together in the end, but I just keep them apart for now. So I get t times t is t squared plus 1t plus 1t plus 1 all over t minus 1, t plus 1 minus t squared minus 1t, oh no, minus 1t minus 1t plus 1, then we get Now, because they're the same denominator, you can write them all over one denominator, which is t plus 1, t minus 1. Now remember, the subtraction sign has to subtract every term behind it. So watch yourself. So this is going to stay the same. T squared plus 1t plus 1t plus 1 minus t squared minus a minus 1, so plus 1t, minus a minus 1, so plus 1t, and then minus a positive 1, so minus 1. Then I can collect like terms in the numerator. So all over one denominator. So I'm going to get t squared minus t squared cancels. 1t, 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 1t is 4 t's. Plus 1, minus 1, they cancel. So it's 4t over t plus 1t minus 1, which also happens to be this, because it's the difference of squares. So they just put it back together, so it's the same answer. I like it better simplified, but it's a multiple choice, you need to match what they have. This is not as simplified. So this is better to me. Now, here we have x minus 7, and here we have 7 minus x. They sound the exact same, but wrong sign. So we can fix it by just taking a negative 1 out. So we get 3 over x minus 7 minus 5. And then if I take a negative 1 out, I get minus 7 plus x. And then these are actually the same. Positive x minus 7 minus 7 plus x. Now, instead of having to multiply this one by negative 1, I can just bring, if it's just a negative 1, I can just bring the negative 1 up here. So I'm going to get 3 over x minus 7 minus negative 5 over x minus 7. Same denominator, so I can write it all over one denominator. And in the top, I get 3 minus a minus 5. So that's plus 5. So that's going to give me 8 over x minus 7. And my restriction here, the x can't equal 7. Which is A. We have one more. All right. So now we have a binomial of y plus 2 and a binomial of y minus 1. Can't take on a GCFs. Can't do a difference of squares. They're binomials. They do not match. So when they do not match, these are the easiest questions. So when they do not match, just multiply them by each other. So we're going to get 3 over y plus 2. There's a leave space for a common denominator. And then 1 over y minus 1. And then I'm going to multiply this one by y minus 1. On the right hand side by y plus 2. So when they're binomials and you can't make them any more simplified to be each other, just multiply them by each other. Distribute the tops, not the bottoms. And how do I know that? Because they want it in this form where the bottoms are not distributed. So why the heck would I distribute? Right? So I'm going to get 3y, equal sign running down the left, 3y minus 3 all over y plus 2, y minus 1, minus, distribute 1 into nothing, y plus 2, over y plus 2, y minus 1, equals, one common denominator now, y plus 2y minus 1. I wrote the plus 1 first because in their form that they wanted in, they put the plus first. Now I'm going to get 3y minus 3, and then the common error is going to be for you to forget to distribute that minus 1 through. So if you do not remember to do that, every single question on your diploma will be wrong that has this, and every single unit test question, and every single of your mock test questions will be wrong. So do not forget to distribute that through. So we're going to get minus y minus 2. Then you collect like terms. So we get 3y minus y is 2y. And then minus 3 minus 2 is minus 5 over y plus 2, y minus 1. Now we need to match. So it is of the form ay minus b over y plus c, y minus d. And we have to make sure that we pick out what we need to. So it says a in the first box, b in the second, c in the third, d in the fourth. Okay, so a is what's in front of the y. So it's 2. B is not the minus sign. B is what's beside the minus sign. So some people say, well, I can't fill negative 5 into my numeric response box. You're right. Negatives can't go in. So they do it in a certain way that it forces you. See, it's minus B. So this is minus B. B is 5. And it's y plus c. Y plus c. That's why I know 2 has to come next. And then y minus d. Y minus d. So that's why I know 1 has to come last. 2, 5, 2, 1. Ooh, last thing, solving rationals. I know this is a long podcast, but remember, people who study for their diploma do well on it. People who do not do way worse than their mark, and that's just so sad. So we're studying, 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 because when we come back, we only have 6 days of classes before your diploma. 6 days. That's nothing. You've had 18 days off, and we have 6 days. So we need to do some review before those 6 days. Solving rational equations. Always state non-permissible values and check for extraneous roots. So you can solve by cross multiplication. This is when you have a full fraction on one side and a full fraction on the other. I'm going to show you this option, but it only works, and we haven't went over it before, but it only works if you have a full fraction equals a full fraction. So when I have a full fraction equals a full fraction with nothing else, I can actually cross multiply. I can go this times this. So I get 1 times x squared minus 1 equals 4 times x minus 1. Then I distribute. I get x squared minus x, 4x minus 4. I have to get everything to one side. So I subtract my 4x, and I add my 4. And I get x squared minus 5x plus 4 equals 0. And then we factored it. Well, multiplied to give me 4 and add to give me negative 5. Now, if you forget factoring, not a big deal. This is your A, this is your B, this is your C, and the quadratic formula is on the very bottom left of your formula sheet. And it says in the form ax squared plus bx plus c equals 0, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we get x equals minus a minus 5, so plus 5, plus or minus b squared is negative 5 squared minus 4 times a, which is 1, times c, which is 4, all over 2 times 1. So x equals 5 plus or minus 25 minus 16 is 9 over 2. Oh, it's really long. X equals 5 plus or minus 3 over 2, and then it splits. X equals 5 plus 3 divided by 2, which is 4. X equals 5 minus 3 divided by 2, which is 2 divided by 2, which is 1. So, say they go this route. Say they show you it as a factor, and you're like, uh-oh, I don't know, I can't do factoring. Your quadratic formula, you get x equals 1 and 4. If I solve this one out, I get x equals 1 and 4, so we're good. Okay? But it says here, Leo's answer is not correct. Explain the error in his work. NPVs, non-permissible values. So that's why if you do cross multiplying, you have to watch yourself. This one is 1 over x minus 1 equals 4, and then we take an x out, and then we're left with x minus 1. So we actually have x count equals 0 or 1. Look at that. One of our answers is 1. So we're going to go x equals 4. Leo should have went x equals 4 and boxed it, saying that solution. And then x equals 1, circle it, put a line through it, and he should have said extraneous. there's Leo's error, and it's in line 5. And you have to explain it. So how you would explain that is you'd say his error is in line 5 because he didn't check for restrictions or non-permissible values. 1 is not allowed, therefore it's extraneous. So you have to explain it in a sentence. Remember? Explain. Okay. So this one I have 2 over 4 minus y. Oh, my board. Don't worry. It's still the same. All right. They've been doing so good. Okay, so if we go 2 over 4 minus y equals 3 over 1. If I want to solve, I can make common denominators. That's the key thing. So this one is 4 minus y. This one is 1. So this one I need to multiply by 4 minus y. So I get 2 over 4 minus y. Now, some people are putting left-handed equal signs running down here. Solving is the only place where you don't put that left-handed equal sign. I'm glad you're putting left-handed equal sign because that means you're listening. But solving is the only place where we don't need that. So we have an equal sign running down the middle because that's where it exists. So we get 3 times 4, which is 12. And then 3 times negative y, which is minus 3y. All over 4 minus y. Now, if I have, remember, this denominator equals this denominator, before I just go and write the numerators equal, I have to do my restrictions. We never cancel off our denominators until we do our restrictions. So I have 4 minus y can't equal 0, and then I can just add the y over. 4 can't equal y. Now, if this denominator equals this denominator, remember I pulled the highlighter out and I would always say, then this numerator must equal this numerator. Go back to our pen. So once we have common denominators, we can set the numerators equal. 2 equals 12 minus 3y. Subtract 12. Negative 10 equals negative 3y. Divided by negative 3. And y equals 10 over 3. And then I follow behind with my non-permissible values always, because if I forget to check for extraneous, this will at least make me check it. Y can't equal 4. It's B. Okay. This one, I have the solution of the rational equation 4 over x plus 2 over x, 2x over x minus 4 minus 2 to the nearest tenth is what? So I have 4 over x plus 2x over x minus 4. And then I'm going to add this 2 over. It's easier to deal with then. Equals 2 over 1. Now this is a monomial x. This is a binomial x minus 4. I can't make them be the same. I specifically picked this because people think if they multiply by negative 4, they make a match. But negative 4 times x is negative 4x, which is actually nowhere any better than what you have right now. So when you have a monomial and a binomial denominator, you have to multiply them by each other. So I'm going to multiply this one by x minus 4. And this one by x. And then this one I have to do both. So x and x minus 4. But the x can just join the 2. Remember, we don't distribute our denominators. There's no point. It's going away. So I only distribute the numerators. So I get 4x minus 16 plus 2x squared over x minus 4 equals 2x squared minus 8x. Now people might be freaking out because they see the x squared. This one's actually nice because the x squareds are going to cancel. So once I get my denominators equal, I can set my numerators equal. Before I do that, I have to state MPVs, or restrictions. So I have x can't equal 0, and I have x minus 4 can't equal 0, add the 4, x can't equal 4. Now, really, you can't complain about reviewing over your Christmas holidays, because guess what I'm doing? This over your Christmas holidays. So, we're both reviewing, both taking some time. Now, I have denominator equals denominator. So when I have that, I can say that my numerator is equal. And so I'm going to go 4x minus 16 plus 2x squared equals 2x squared minus 8x. Now, I can subtract 2x squared from both sides, and it actually goes away, and I don't have a quadratic, and I don't have to use the formula. Yay! So I get 4x minus 16 equals negative 8x. My next step is to get my x's together, so I'm going to subtract 4x. So I get negative 16 equals negative 12x. Divided by negative 12. And x equals, take a 4 whole, so 4/3, which equals to the nearest 10th, that's one decimal place, 1.3. All right, lucky here, last one. Okay, last one, and it's in a large piece of paper. So here it says state the non-permissible values of the variable, then solve each rational equation. So we only have one here. Being nice. And then verify. So we're going to verify that they work in the end. Or don't work. So here I have 2 over m minus 3. That's a binomial. Equals 1 over m. That's not an equal sign, that's a plus sign. Come on, grab a mitt, get in the game. Okay, plus 1 over m. Monomial equals 6 over, and I can take an m out, and then I'm left with m minus 3. So this actually has both of them. So it's only the left-hand side that I actually have to make the same. Common denominators. I need to multiply this one by m, and this one by m minus 3. So I distribute my numerators, I don't my denominators, because the denominators are going to go away, so there is no point. So I'm going to get 2m all over m minus 3. No point in distributing it, it's going away. Plus, and when I distribute a 1, it does nothing, m minus 3 over m minus 3 equals 6 over m minus 3. Currently, the denominators are not equal. The left-hand side has a plus sign. It's not a full fraction. So you need to have full fraction equals full fraction. So now I can write this left-hand side all over m minus 3. So I'm going to get 2m plus m minus 3. It's nice when it's a plus sign, so remember to distribute. Equals 6 over m minus 3. Then I can take and make this be a 3m minus 3, collect our terms, over m minus 3 equals 6 over m minus 3. Now my denominators equal, so I'm going to be able to drop them off, but I can't drop them off until I state it to these. So my non-permissible values are m can't equal 0. That one's done. M minus 3 can't equal 0, so m can't equal 3. Now that my denominators are equal, I can set my numerators equal. So I get 3m minus 3 equals 6. Add 3. 3m equals 9. 5 by 3. M equals 3. But my non-permissible values say m can't equal 0 or 3. So that means I circle this, I put a line through it, and I say, strange, And since the only solution is extraneous, we're actually going to say no solution. That's your review for today.